All right, this is the review packet, topic 19B and C, number 32. So we're going through and trying to find out which of the following statements is not true. Well, if I have this exponential function here, this is the parent function, there's nothing after it, it's not moving at all, I have a base raised to a power. So that means this has a horizontal asymptote at y equals 0. I know that. All exponential functions have a horizontal asymptote. For the parent function, it's at y equals 0. That means B is true, and I'm looking for one that's not true. Also, I know that all parent functions go through 0, 1. Well, the y-intercept, yep, that's also true. The reason for that is anything raised to the 0 power is always 1. So it doesn't matter what A is. It could be 10, could be a million. Raise it to the 0 power, you get 1. So C and B are definitely true. Then I look here. If A is between 0 and 1, so if the base is a fraction, that's what this is saying. If the base is a fraction, it's exponential growth. Well, that's not true, right? If the base is a fraction, that means it's exponential decay. So that's not true. Then we just look at D. So again, it's saying if the base is a fraction, so like this is decay right here. If the base is a fraction, as x approaches infinity, so as x goes more and more this way, y goes into infinity. Well, this one is also false, because as I go toward infinity here, my y value is getting closer and closer to 0. It's not getting closer and closer to infinity. So I have two false ones, A and D. All right, on 33, what is the range of the function defined by f of x equals negative 1/3 to the x plus 2? All right, so for exponential ones, I know that I always have a horizontal asymptote, and this horizontal asymptote is at y equals 2. It's that piece right there. So I know that this negative means it's reflected. So instead of having, this would be decay, but instead of having decay, it's going to be reflected, and it's going to look, instead of like normal decay here, let's see if we can, my normal decay type thing would be like this, but now I'm reflected, which means it's going to be more like this, whoops, but going toward this asymptote at 2. So again, this would be the original, this is the reflection, and what that means is my y values for the reflection stop at the asymptote. So I go all the way from negative infinity, and then I stop at 2. So that means my y values are going to be less than 2. Because they can't be 2, I don't touch the asymptote, and I don't have anything above the asymptote. Okay, number 34. Which equation best represents the graph below? Well, we can tell this is exponential, and I can see that it's exponential with an asymptote right here at negative 3. So there should be a minus 3 after it, so it can't be B, it can't be D. And then, let's see, it's decay, so my base has to be a fraction. So my base of A is not a fraction, so it's going to have to be C. And I could also put these in my calculator and do it that way too, but just looking at the graph, again, I did it by knowing that this is an exponential one, and I have a horizontal asymptote, which happens to be at negative 3. So I eliminated B and D because these are both plus. And then I also know that it's decay, which means that I have to have a fraction. And so 2 is not a fraction. My base here is a fraction. So last one, what is the domain? Well, my domain is x values. And this one has a vertical asymptote at negative 4, which means it's never going to touch negative 4, and it can't be negative 4. It's going to be everything to the right of negative 4. So it's going to be greater than negative 4.